So in this video we will study about the Dalton's law of partial pressure, and according to this law the total pressure of a mixture of gases equal the sum of pressures that each would exert if it present alone. So Dalton pressure law is says that if one container has 3 or 4 individual gases, kind of mixture of gases, so the mixture of gases have the total pressure of the mixture of gases will be equal to the individual pressure of gas. So PT means P total pressure of total pressure of a mixture of gases will be equal to pressure of one gas, pressure of two gas, pressure of three gas, and pressure of so many other gases which are present in that container. So let's see one example numerical problem for this question, and then we can understand better. So a mixture of 1 gram hydrogen and 1 gram helium is placed in 1 liter of container and that contain 27 degrees Celsius. Calculate the partial pressure of each gas and the total pressure. So how we will calculate? This is very easy and simple question. So what to do first? First we will write what are the values are given in the question. So you can see W means W of hydrogen is given 1 gram and W of helium is given 1 gram, and volume is 1 liter, and then pressure temperature is 27 degrees Celsius, and now we have to calculate the partial pressure of each gas. So partial pressure of hydrogen, partial pressure of helium, and then total pressure we have to calculate. So again we have to utilize the ideal gas equation, which is PV is equal to small n RT, and PV is equal to small W over molar mass RT. And so since we have to calculate only pressure, so pressure will be equal to W over molar mass and then RT over volume. So now we will use this equation and place all these values in this equation. So first for in case of hydrogen gas, you can see for hydrogen gas we will place weight of hydrogen, which is 1 gram. R is gas constant 0.0821 liter atmosphere per mole Kelvin, then multiplied by 27 degrees Celsius, which is we need to add 273, then it will become Kelvin, and then divided by molar mass of hydrogen gas. So hydrogen gas is a diatomic gas and we know atomic mass is 1, so for H2 it will be 2 gram per mole, and then 1 liter is container, and now it's easy. We can replace all these numbers on the left hand side and then units on the right hand side, and we can cancel out all the common units. Since we need to get the partial pressure, so pressure will come in atmosphere, so atmosphere will remain unit for partial pressure in atmosphere remains, and remaining other unit will be cancelled out. So 1 gram multiplied by 0.0821 multiplied by 300 divided by 2 multiplied by 1. So this will become 12.315 atmosphere pressure. So this was the partial pressure for hydrogen gas, and let's see the partial pressure for helium gas. So everything will remain same. You can see 1 gram of helium because the quantity is same for the as hydrogen and helium. R value will same, temperature will remain same, 1 liter volume will same, but molar mass will change because helium have molar mass 4 gram per mole. So once you will multiply all these values and divide by these 4, you will get an answer in 6.158 gram 8 atmosphere. So this was the partial pressure for helium and this was the partial pressure for hydrogen, and now what we can do, we can just add of these partial pressure to get the total pressure. So total pressure will be equal to hydrogen pressure, which is 12.316, and then helium pressure, which is 6.158 atmosphere. Once you will add these two together, it will come 18.57 or 18.5 atmosphere. So this was the question about the partial pressure and the Dalton law partial pressure. In this way you can calculate any partial pressure for a gas. In next video we will study about the mole fraction.